This is Mr. Ashton going through the Mathematics Numeracy Unit 1 Non-Calculator Higher Tier Autumn November 2018 papers. Okay, because this is the higher tier paper, I've already done the intermediate version of this paper, so the first half of the question is already done with the video that is linked below. But if you go on to question 8, I'll go through here then. But if you want questions 1 to 7, just go back to the intermediate paper. So the first question that was just on the higher paper, you'll be wanting to use the annual equivalent rate from the formula booklet here. So I'm just going to write that in very quickly here. 1 plus I over n to the power of n take away 1, where I is the nominal interest rate. So I'm just going to highlight that. I is the nominal interest rate, and n is the number of compounding periods. Okay, so if we go into the question now and we start reading through this, let's have a look to see if we can highlight any of those things there. Well, first of all, you can already see what the nominal interest rate is, 4%. So that will be that. Now, that's always written as a decimal. It does say, if we go back to the formula, that that's written as a decimal. Number of compounding periods is 6 every 6 months, so the number of compounding periods would be 2. Okay, let's just read the question quickly and make sure we have got our head around what's going on. It says, Kellen is planning to invest a sum of money in a savings account. Kellen has picked up the following leaflet offered by a local bank. The details are shown below. Blah, blah, blah. Calculate the AER that the GAR rate is offering. Now, this is really mean because it's usually a calculator question. But what we're going to have to do is sub in the numbers into this and do it without a calculator. So first of all, I is 4%, but we said we have to write that as a decimal, so it's 0.04. And n is the number of compounding periods. How many times the 6 months go into a year? Twice. Okay, so n is equal to 2. So that's where we'll be looking for those things to be going. Okay, so what we need to do now is do 1 plus 0.04 over 2 squared, and then take away 1. Okay, if I simplify that, then 0.04 over 2 is 0.02 plus 1 would be 1.02 squared. So what I need to do is work that out now. Now, without a calculator, just be careful, it's not as simple as you think. I'm going to partition it into 1 and 0.02 times by 1 and 0.02. Okay, 1 times by 1 is 1. 1 times by 0.02 is 0.2. 0.02 times by 1 is 0.02. And this is the one that you're likely to get a mistake on here. 0.02 times by 0.02 is not 0.04. 0.02 is the same as 2 over 100. And I'm times it by itself, 2 over 100. So that is going to be 2 times by 2, which is 4. And then 100 times 100, which would be 10,000. Okay, so the actual decimal that you should have here is 0.00004. Okay, so very easy to make that mistake there if you don't think of it like fractions, or be aware that when you times a decimal by a decimal, the answer gets smaller. So then, adding all of those together, I can say that is 1.0.02 plus 0.0.2 is 0.04. So that will put us there. So then it's going to be a 0.4 there. Okay. Now, the one thing that I haven't done is I haven't taken off 1 off that yet. So as a decimal, that's 0.0404. And then finally, as AER, you times that by 100, so it would be 4.04. So it's only ever just so slightly bigger than what it says. Then asked me to give a reason why the bank uses AER. If you're ever posed with that question, the answer is simply that you just fairly compare interest rates over the same time period. Okay, so I'm going to say to fairly compare interest rates over the same time period. Okay. Okay then, over the page, and we get part C. Okay, have a quick read of the question and I'll go through it. Okay, it says Kellen decides to invest his savings of £3,000 into the GAR savings account. He plans to save enough money of the motorbike costing £3,200. Calculate how much short of the £3,200 he would be after 1 year. Now, that's basically the question that we just did. So where is it? There. So what you do is you do 3,000, which is amount, times by 4.04. But without a calculator, that's going to be really, really hard. So I'm just going to do it into 2 stages, which is 4% every 6 months. So I'm going to say start. It won't be 4%. That's the nominal annual rate. So because it's paid every 6 months, it will be that 4% divided by 2, which is 2%. So at the start, we have £3,000. We're then going to do it 2%, which although it says 4%, that's because it is the nominal interest or nominal annual. We're doing it every 6 months. So because 6 months is half of a year, half annually, we then half that as well, okay? So 2% would then be equal to, 10% would be 300, 1% would be 30, so 2% would be 60. So at the end of that year, we would have 3,060. So then at the start of the new year, we'd have 3,060. And then we would find 2% of that. So again, 1% will be £30.60. So 2% would be £31. No, wouldn't it be £61 and 20 pence? So then at the end, once I add that on, that would be £3,121.60. Okay. Now, as always with the numeracy paper, it says calculate how much short of the 3,200. Now, I don't really want to put that into column addition, so what I would do is say £3,121.60. Journey until 3,200. Well, first of all, let's add 40p. That would take me to 3,122. And then I'm going to add £8, which would take me to 3,130. And then to get there, I would add £70. So £70 plus £8 plus 40p will give me £78.40 short. Maybe slightly easier than actually doing column addition there. One thing that I do want to show you really quickly is that if I do 3,000 times by the AER, so times by the multiplier, so 1.0404, it should give me the same answer that I had there. Oh, just spotted a mistake from here. Look, 20p there. It should be 20p there. And if I actually used, yeah, so that answer is going to be wrong as well. So that's 20p there. So that should have been 80p. That's just as well I checked it, isn't it? And then that should be 80p there. Okay. Right, lovely. So, yes, mistake there from adding that onto that. That should have been 20p, as you can clearly see from my working, which then factored into that. So it should have been £78.80. Okay, then over the page, have a quick read of the question, get your head around it, then I'll start going through it. Okay, it says a group of pupils sat their mathematics test. The teacher grouped their marks into intervals of 1 to 20, 21 to 40, and so on. She then drew the following cumulative frequency diagram to display the results. Phoebe says the cumulative frequency diagram shows that the median mark was 70. Explain why the median mark may not be 70. Well, let's just go and check her claim, shall we? So she claims it's 70. We can see that it finishes on 60. So if we go across at 30, there, and come down, yeah, you would assume that she's correct to say, yeah, that's 70. The median is equal to 70. And we're asked to explain why that may not be the case. And it's all to do with these groupings, okay? We're grouping them here to here to here and so on, okay? So basically, the reason why is, I'm going to say, although it appears to be 70, it will be somewhere between 61 and 80 if you follow those groupings. Somewhere between, that should be. Somewhere between 61 to 80 due to the groupings. Basically, you plot at the endpoint. So at 20, you plot how many people were there. So 2 were there, then 6 were there, and so on. And it's just so happened that from this dot to dot that we've joined up, that 70 is the median. It's not necessarily the case, but it'll be a good sort of a description of roughly where the median is. It will be somewhere between 60 and 80. It then says for part B, it says, consider the pupils who had a mark of 80 or less. How many of these pupils would have needed to score more than 80 for Phoebe's estimate of the median to be 80? Okay, so I don't think she actually says it's 80 anywhere, is it? So it says how many of these pupils would have needed to score more than 80 for Phoebe's estimate of the median to be 80. Okay, so if we look at the number of people who have scored 80 or less, I make that 42 people who've scored 80 or less. Now, if we're trying to make 80 the median, we want that to be 30 and not 42. So basically, we need 12 more people to have hit above 80. So I think that's what it's asking me. Let me just have a quick check. It says, how many of these pupils would have had to score more than 80 for Phoebe's estimate of the median to be 80? Yes. So coming back here, we'd need another 12 of these people to be above 80 for that to have been the median. So it's 12 more people. Okay, the next question says, each of 250 Year 10 pupils in Blind Gwyn School study one foreign language at GCSE. The tables show the pupils by French, German and Spanish. The language department is planning to take a group of 30 pupils on an educational trip to Europe. Use stratified sampling method to calculate the number of Year 10s from each language that should be taken on the trip. Okay, so what we need to do is we need to know the number of pupils who took it, so 250 Year 10 pupils. We then need to know how many they want, so 30. Okay, it's a little bit like working out a percentage here. So what we're going to do is we're going to work out the number of French people who study French who should go would be 75, which is the number who took French, out of the total, and then we're going to times that by 30. Okay, now there's a couple of different ways to do this. The first way I'm going to do it is going to start cancelling down that fraction to make it easier on myself. So I know 5 goes into 75 15 times, 5 goes into that 50 times, times by 30. Now what I could do from that quite easily is I could turn that into percentage. 15 out of 50 is 30%, so it'd be 30 out of 100. I might just try cancelling down the fraction again one more time. So divide by 5 would be 3. 3 tenths of 30. Well, 1/10 would be 3, so 3/10 would be 9. So we should take 9 people who study French. Let's now do German. So German is going to be 55 out of 250 times by 30. So that's going to be 11 out of 50 times by 30. Now, this is the problem this time. I can't go and work that out nicely. I don't know what 30 divided by 50 is. So what I'm going to do is turn that into percentage. So 11 out of 50 is the same as 22 out of 100. So I want to work out what 22% of 30 is. So 22% of 30. Well, we know that 10% would be equal to 3. 1% would be equal to 0.3. So 20% would be equal to 6. 2% would be equal to 0.6. So 22% is 6.6. Now, obviously, I can't take 6.6 students. So you would suggest that that will round up to 7 students. So we're going to have 9 for French, 7 for German. And then let's just check. Now, we know that there's 30 pupils going all together. 9 and 7 makes 16. From 16, that should be 14. So let's just double check that now with the maths. Okay, so what I should do for Spain is 120 out of 250 times by Spanish times by 30. Now, if again, I can make this as a percentage quite easily. If I divide top and bottom by 10, I get 12 out of 25. So to make that as a percentage, it's going to be 12 out of 25 going into 100. So it's going to be 48%. So if I work out 48% of 30, well, I know what 50% is. 50% must be equal to 15. And then 10% would equal 0.3. So 2% would equal 0.6. So if we take 0.6 off there, we get 14.4. So that would suggest that we'd round that to 14, which is exactly what we had. You always have to make sure that this table will add up to the number we said, 30, and those numbers will. So that is how we do a stratified random sample fairly. Okay? Okay, a bit of a nasty one here again. Read the question, pause the video, make sure you've read the question, understand it as best as you can. Okay, so this question was all about upper and lower bounds. The way that I noticed that was these statements. They haven't done that here. Okay, now the first thing I'm going to do is go and write down the upper and lower bounds of each of these things here. Okay, so I'm going to say lower bound, upper bound, and then S, and then U, and then V. Okay, now when I'm doing it to the nearest 5 meters, we halve that to get 2.5. We would halve to the nearest ms to the minus 1. That would be half of 1, which is 0.5, and the same here. So if it just says the nearest, it means the nearest 1, okay? So the S, the slowest bound of the S could be 195, take 2.5, which would be 192.5. The upper bound would be adding on that 2.5 instead, so we'd have 197.5. The lower bound of 5 would be 5 take away 0.5, so it would be 4.5, and this would be 5.5. Similarly here, this would be 13.5, 14.5. Okay, now you'll get a mark for just working out those, if not 2 marks. We're then asked to work out, it says, using Allen's model, calculate the least possible time that could be taken to travel this bit of the zip wire using this formula here. Okay, now if we're trying to get the least possible time, then what we want to do to this formula is we want to have the smallest answer we possibly could up on the top divided by the biggest number. So for instance, if I was going to share 20 quid with the 2 of us, we get £10 each. But if I reduce the amount of money that I was going to share, so if I take 20 quid, I'm going to reduce that to 10 quid and share that by more people, by you, me, and 5 other people watching this video, I'd have £10 share between 7 people, so we get dramatically less each, okay? So to do that, I want to do T is equal to the smallest possible amount I could have had, times by 2, because it's 2s, and then divided by the biggest possible answer for U and V. So the biggest possible number here would be 5.5, the upper bound, add the other upper bound. So 5.5 add 14.5. Now, before you start trying to make everything really, really hard, let's just work this out first on the bottom. So I'm going to leave that as 2 lots of 192.5 divided by 20. I'm now going to divide top and bottom by 2. So that is now 192.5 divided by 10. And then 192.5 would be 90. And then that would be, because it's a time, that would be in seconds. Okay, now over the page you've got something very similar. It says a second pupil, and again all of these things measured to the nearest. So again we need to do exactly the same method as I just did. We're going to have lower bound here, upper bound here, and we're going to have u, v, and t. Now these are all to the nearest, so just divide each of them by 2, and you're going to get 0.5 for each of these. And then we want to just take them all off the lower bounds, so 7.5, 20.5, and 13.5. And then for the higher bound or the upper bound, you're going to have 8.5, just literally add 0.5 to each of them, 21.5 and 14.5. Now, read the question, what we asked. It says, using using Alid's model, calculate the greatest possible distance that she could have travelled. So the greatest possible distance, we're going to need to get the distance, which is s, by itself first. We're going to have to do some rearranging. So we've got t is equal to 2s over u plus v. Now, I want to get that s by itself first. So the first thing I'm going to do is take these two things over to the other side to get t equals u plus v. In a bracket, it says two things there is equal to 2s. And then to get s by itself, I want to divide this side by 2, and it will still be exactly the same thing as before. So, because I want to get the greatest possible answer here, I want the t to be the biggest value. I want everything to be really big. I'm not dividing by anything here. It's literally just make everything as big as possible. So it's going to be 14.5 bracket u, so 8.5, plus 21.5, close brackets. All of that answer divided by 2 is then equal to s. Now, there must be some easy way of doing this. That's why I put it in a non-calculated paper. 8.5 plus 21.5 is 30. So we've got 14.5 times by 30. All divided by 2 is equal to s. Now, from here, what I'm going to times that 30 out here. I don't like the decimal. I'm going to do 14.5 times 10, then times that by 3. So it's going to be 145 times 3 over 2. And then 145 times by 3, or 150 times by 3 would be 450, but we need to come back 15. So it's going to be 435 over 2 is equal to s. And finally, s is equal to half 435. So it's that 217.5, and that would be in meters. Okay. Okay, question 12. Again, pause the video, have a quick read of the question, make sure you've got your head around what it's asking, and then I'll go through it in a moment. Okay, so it says, an architect has been asked to design a square-based pyramid, glass pyramid, that has to be built in a park. The vertex at the top, so that's just the corner, this thing here, this is what they're talking about when they say that vertex, is directly above the centre. Now that's really important. You'd assume that if they hadn't told us anyway. So that goes into the middle of that square, because it's a square-based pyramid. What's it say there? The edges of the pyramid will be made from steel. Each sloping face will be made from glass. Okay, so these bold lines are steel, and then in the middle is glass. Okay, part A. The architect first plans to make a scale model of the pyramid. The scale model will have base size of 14 to 14 and a height of 8. So they told us what that is, they told us what that is. It then says calculate the length of each sloping edge of the model. Okay, so they want me to work this out. That's what they're talking about. If each sloping edge, that's what they're after. Okay, now to do that, you need to spot the Pythagoras that is going on in this question, which is not drawn very well by me there, which is here. Okay, there's a right angle triangle here. So maybe that will come through a bit better. We know this is 8 centimetres. We know that all of this is 14. What we don't know is what that length is at the moment. Okay, but what we do know is this is 7 centimetres. This would be a right angle. And because it's centimetres, so this far must be 7 as well. So I can work out this blue line here by doing 7 squared plus 7 squared is equal to what I'm just going to call h for the hypotenuse squared. 7 squared is 49. 49 plus 49 is 98 is equal to h squared. So I'd square root 98 and have h. Okay, so we now know what this is. This is root 98. Okay, to then go and work out the sloping edge, which I'm going to call s, that's Pythagoras again, where I'm going to do 8 squared plus the square root of 98 squared to equal s squared. So root 98 squared plus 8 squared is equal to the sloping edge squared. Root 98 squared root of 98 squared cancels out to give me 98 plus 64 is equal to s squared. 98 plus 64, well, if I add 2 onto that, takes you to 100. And then square root 162 to get s. Now, they want me to write this into a form a root b. So what that tells me is there's a square number that goes into 162. So write out your square numbers, 1 squared, 2 squared, 3 squared, and so on. Go up to probably 12 squared. Not a bad idea to know up to 15 squared. Can you spot a square number that goes into 162? So come down from biggest to shortest. 144 clearly doesn't. No. 121? No. 100? No. 81? Yes. Okay, so now we know 81 goes into that. Well, I've got a bit of space on the other side. I'm hoping so. Yeah, I've got a bit of space here. So if I write out root 162 is equal to s, write out square number that goes into it. How many 81s go into 162? 2. 81 times root 2 is equal to s. Then the square root of 81 is 9 times by root 2 is equal to s, which is 9 root 2, which is equal to s. Okay? And then we are asked underneath, halfway through that's the last question now, we've got one more big one to go after this. It then says the area of each glass face on the scale model is 74 centimetres squared. The full-size pyramid is to have a vertical height of 1.6 metres. Okay. Give those, use those values to calculate the area of each glass face on the full-size pyramid. Give your answer in centimetres squared. Okay. Now, look at this so far. That was in centimetres squared. They want it in centimetres squared. Lovely. They usually try and trick me through the units here. 1.6 metres. And we know that the height is 8 metres. So the bigger pyramid, so if I just draw, I'm just going to draw it like that for now, and then I've got my tiny little scale. We know that is 8 centimetres, and we know this is 1.6 metres. Well, they've got to be in the same units of measure. So I need to change that 1.6 into centimetres, so it's 160, and then I can work out the scale factor. How many 8s fit into 160? 20. The scale factor is 20. So that tiny little model I've made, it's going to be 20 times bigger than real life. Then, because I'm working in area, I do the small area times by the scale factor, let me say small area, times by the scale factor squared to get the big area. So the small area is 74. I want to times that by 20 squared to get the big area. 20 squared is 400. I'm going to times that by 4 and then times it by 100. To times that by 4, I'm going to double it. Doubling 74 would give me 48, so 148. So it's going to be 148 times by 200 still. And then timesing that by 2 is going to give me just under 300, because 150 would give me 300. So give me 296 times by 100, which would equal 296. 100, 0. So it would give me 29,000 centimetres, 29,600 centimetres squared. Okay, the final question on this paper, and it is a really big one, really hard one without a calculator, I have to say. We're asked to basically work out what is the surface area of this diagram. So if you read through the question, that's what it's asking us to do. To work out the surface area, we've got to go and work out the things that we know, the areas we know. So I can see there that the whole thing is covered in icing, so I can call that A, that B. Now we'd have this thing that goes around the full side, C, and we'd have the area of the top, D. A is quite easy to work out, B is quite easy to work out. We're told that this cylindrical cake has a radius of 12, so we know that's 12. And then we're told it has a height of 10, so we know that's 10. So A is just a rectangle, which is going to be 12 times 10. That's 120 centimetres squared. B is exactly the same, it's just on the other side. It's still going to be 12 times 10, which is 120 centimetres squared. Okay, so those bits are fine. It's working out C. Now C is a rectangle that's pulled all the way around here. If I was to stretch it out, it would have this height here, and it would have, oh, I've gone off the page there. It would look like that stretched out, okay? Now this is where it's hard. This bit ordinarily would be the circumference. We know it's a height of 10, so I can say it's 10 centimetres, but it's not a full circle. It is 300 degrees out of 360 degrees that would make the full circle, times by the formula that we use the circumference, so times by 2 pi r. Okay, that's what we're going to have to do to work out C. Now 300 over 360, I'm going to divide by 10 initially to make it 30 out of 36, times by 2 pi r, so 2 pi. Now again, I can see that they both have 6 go into it, so how many 6's go into 30? 5, 6, times by 2 times by 12, 24 pi. Okay, 5/6 of 24 pi, well 1/6 would be 4, so 5/6 would be 20. So C has not an area now, has a length of 20 pi. We then need to times that by 10 to work out its area, okay? So it's going to be 20 pi times by 10 to get 200 pi centimetres squared. And for D, we've got something similarly as fussy. It's a circle, so it's again going to be 300 out of 360 times by pi radius. Oh, it's not 12. Sorry, it's not 14, it's 12. 12 squared. Make sure that's nice and clear. Okay. Now, 300 over 360 I already know comes down to being 5/6 times by 144 pi, because 12 squared is 144. How many 6's go into 144? I don't know, but I do know 12 goes into it because I just did it. So if I make that as an equivalent fraction, I've times 6 by 2, so I need to do 5 by 2 as well. So it's the same as asking what's 10/12 of 144 pi. Well, 1/12 is 12. 12 times by 10 would be 120 pi centimetres squared. So my total surface area, over onto the other side now, where is it? There, is going to be 120 centimetres squared plus 120 centimetres squared plus 200 pi plus 120 pi. So that is going to give me a total of 240 plus 320 pi centimetres squared, which I could have just written there as well. It's the same thing. Okay, hopefully that was useful. If it was, please hit the subscribe button. You'll get first access to any videos that I make in the future. Thanks for watching.